Welcome to Part 3 of Lecture 8.1, Definitions and Common Roots. We're going to explore the Pythagorean theorem again. And if you remember, Pythagorean theorem was c squared equals a squared plus b squared. Now that we know we have this power of square root, we can actually solve for the value of c. So c will equal the square root of a squared plus b squared. Do keep in mind that this is for a right triangle only. We have other tools at our disposal for triangles that are not right triangles. For right triangles, we're going to use Pythagorean theorem. C equals the square root of a squared plus b squared. Now, how can we use that? For example, let's have a tent pole that is 8 feet in height. 8 feet in length, we stand it up, and it makes a 90-degree angle with the ground. One end of a rope is attached to the top of the pole and the other end of the rope is anchored to the ground 6 feet away from the bottom of the pole. Let's find the length of the rope. So here's our picture. So here's our pole, our tent pole, and that's 8 feet high. And here's our ground, and the rope is tethered 6 feet away from the bottom of the pole, and it is also attached to the top of the pole. What will be the length of that rope? Perfect example for the Pythagorean theorem. So let's have x equal the square root of 8 squared, that would be our a squared, plus b squared, which is 6 squared. 8 squared is 64, 6 squared is 36. So I have our x equals the square root of 64 plus 36. X equals the square root of 100. And therefore, our rope must be 10 feet in length. So the length is 10 feet long. At the beginning of this lecture in part 1 of 8.1, I started chatting about the golden triangle. And here's what's very special about the golden triangle. It's supposed to be the ratio of the golden rectangle is supposed to be very pleasing to the eye. So here's how we actually construct the golden rectangle, and how we're going to figure out what the ratio is that makes it so special. So I'm going to build a square that's side length 2. So I'm going to draw a square with the length of 2. So here's my square. I'm going to order the corners, of the square A, B, C, and D. The midway between C and D, so halfway, this length is 1 and the other length is 1 because the whole side is 2. I'm going to draw a line between this point, which I'm just going to call 0, all the way up to B. Okay. So that is length 1, that is length 1, the other side is 2, and I can tell you the length of this line is square root of 5. Why? Because using our Pythagorean theorem, 1 squared plus 2 squared equals c. Right? The square root of a squared plus b squared will give me the length of side c. Well, 1 squared is 1, plus 2 squared is 4, 1 plus 2 is 5. So it is the square root of 5. Step 2. We're going to drop this diagonal down to the ground. So remember, this is square root length of 5. We're going to leave it at the origin, and we're going to bring it down. So if you measure it and bring it down, we're going to leave that side right there. From there, we're going to form a new rectangle. This new rectangle is going to be from A to C to this new point, all the way straight up to F and back to A. So that's our new rectangle. Now the ratio between the length of the new rectangle and the height of the rectangle is a very special ratio. It is called the golden ratio. So if I take the length of my rectangle is going to be 1 plus this length right here from O to E, which is the square root of 5. So it's 1 plus the square root of 5. And the length of E to F is 2, because that's how we formed it. It's the same length. So the golden ratio is 1 plus the square root of 5 over the square root of 2. I encourage you to go look up the golden ratio. And here's the primary, what it's kind of used for. Well, what's special about it is the way that we see things, it's supposed to be very beautiful to the eye. This application is very pleasing. It's harmonious. It's something that just kind of resonates with people. And you can see it in the Greeks' pictures, like the Mona Lisa is supposed to be painted with this ratio in mind. Architecture, the Parthenon is built with the golden rectangles in mind. So I would suggest that you do a little research on it and see why it's so special and why we figured out how to calculate it. It's not just an exercise in math. It pushes the boundaries of beauty and art and architecture based in math. It's very special. That's it for part 3 of this lecture. So until next time, be seeing you.